Hey everyone, welcome to the Engineering Technology 387 Laboratory. We are going to be building some very exciting projects in this lab, anywhere from building a small robot to making sure that the robot navigates on its own using sensors. We're going to be using hardware, software, mechanics, and we're going to have a great time. You'll really enjoy the hands-on on this particular lab. So let's get started. So in Engineering Technology 387 Laboratory, we're going to be building a small robot that we're going to program, and that robot has sensors, some mechanical aspects to it, such as motors and mechanisms, and you'll also have software. That's really what mechatronics is. It's a combination of software, electronics, and some mechanics. As you can see in the graphic here, there are certain areas that the mechatronic basically bleeds into. You have control systems, digital control systems, computers, mechanical, electromechanical really. And a lot of the industries that use these devices is pretty much everything that you see here: medical, aerospace, materials processing, transportation, robotics, and all those things. So the concept is that you build your own robot, you learn how to program it, you have sensors in there, and you're going to make a robot that has some smarts in it. It'll create smart decisions and things like that. So it's going to be a really exciting lab. There's 5 labs that we're going to cover, but let's first start with some of the things that we're going to be doing here. So again, we're going to have a little bit of electronics. It's a little bit like my workstation looks like in my lab. We're going to have some software programming, and we're going to have some mechanics as well. A lot of the main industries that are using robotics or mechatronics include things like industrial robots, of course, right? Medical robots, aerospace robotics. But there's also other areas that are starting to come up a lot right now, and that is farming, for example, right? Mining trucks that are automated. So imagine if you build a small robot with sensors that think and that moves around and navigates on its own. That would be like building the mining truck. That would be like building this farming tractor or the Roomba, for example. It's the same concept. You have motors, you have sensors, you have mechanics, and you have software. They all have the exact same components. So by learning how to do one, you have an idea of basically the understanding of the inside of how things work. This is the little robot kit that we're going to be using. So the robot kit consists of a lot of parts, and let me find you. Let me find you a little bit of what those parts look like. Okay, that's the electronics of it. Let me grab a different view here. Alright, so these are all the parts that you have, right? You have some of the chassis, you have some wheels, you have some motors over here, right? And you have a computer, which is the Arduino. You have a lot of sensors. You have Bluetooth radio communications, you have infrared wires, and then you have a way to program it, a power source, and a whole bunch of hardware and other sensors, an accelerometer, some other servo motors in here. And so we'll be building this kit, and the kit looks something like this. Right, you have the assembled robot. You have the top level, you have the bottom level here, and you have the wheels, and you have some sensors on the top. You have a computer and some more sensors over here. So this little guy can navigate on its own without hitting something, for example, right? So here's a little bit of the scale of what it looks like. So that's a AA battery. Gives you an idea how big or how tall it is. It's really small, but it does take a little bit of a time to build it. I've gotten pretty good at it. I can assemble one in 15 minutes, but we'll provide you a video of how to assemble each part and a video of each lab explaining how it's supposed to be assembled and working. There's also documents that show you how to assemble it, and a lot of sample code as well. And you'll be given some basic sample code on how to do certain things. In each lab, you're going to have to figure out how to correct that program or make that program extend the program so that it does what the lab is supposed to do. So we'll give you a little bit of an intro, and then you're supposed to figure out via the software and even your own creativity on, you're given a whole bunch of sensors and you can pick and choose which sensors you like to use in some cases, but most of the labs will tell you exactly what sensors you will be using. So you can see a little bit of the top level there. This one is assembled with a ramp in the front, and that's for a sumo wrestling competition. So we have this little robot, we put smarts on it and we program it to seek another robot and push it off the sumo ring. So this is a smart robot based on your programming instructions that goes out and looks for another robot and tries to push it off the ring. And we use that particular ramp in the front. It all comes with the kit. It's the bottom of the kit. It's got some infrared sensors on the bottom so that it can detect a white or a black line, right? So this is used especially in the sumo competition so that the robot knows whether it's inside the ring or is being pushed out. It's also used to follow a line. So one of the labs is for you to follow a line with this particular sensors. And infrared sensors are just light sensors that can transmit a beam of light and reflects it back on the sensor. So that's how you know whether or not something is in front of it or not. Here's the back of it. You got some batteries that go into it. A little bit more about the kit. The kit was designed using Google SketchUp, and it uses compressed wood as the chassis, and it is laser cut. I'll show you a video clip of how that works a little bit. This is some of the chassis being laser cut, and this is how they come out of the laser cutting machine. Alright, so let's go over what we're going to be doing in those labs. So the labs will be based on Arduino microcontrollers, a whole bunch of different sensors. You got infrared, sonar, and some switches as well, and we'll have various ways to communicate with it. You can use it in Apple Macintosh machine, or you can use Linux, or you can use a Windows machine. Okay, a lot of the software that I have has been made basically on a Windows machine, but you can use pretty much any machine to download the software. So the labs is going to be 5 labs total. Okay, 5 labs. They're 100 points each. It's 25% of the it's 50% of the class. So make sure that you do all of the labs. So one of the first lab, we're gonna have some due dates here. The first lab is you build a robot and navigate in a square. It does beeping and blinking at every corner. The second one, it navigates with feelers, or now you have some sensors in it. So the first one navigates by itself with no sensors, but it doesn't know what it's doing, so you're just commanding it to do something. The second time you do it, it'll navigate but with sensors, so now it knows what it's doing. And then the third time you also have a sensor, but now you're following it aligned, and it's usually a competition that whoever can follow a line the fastest to get from point A to point B wins. And the next one is, how do we remote control a robot? We can use IR. If we have time, we can also do a Bluetooth app so that you can use your mobile phone to control the robot via Bluetooth. And then the last one is a sumo robot. This is an intelligent robot that seeks its opponents and tries to push them out of the ring. So it's usually a competition, but it's a fascinating one that we do. All right, so let's go over each one a little bit more detail. And let's get here. Okay, I'll just show you a little bit what Lab 1 is supposed to look like.
This is a demonstration of the robot. When you turn it on, let's read the program.
This is one of the students who did it in his home.
Approximately 3 feet. Makes a turn and beeps and lights the LED. With its other turn.
So after you assemble and test the robot, you write
where it started.
You write a program that does that. It goes in a 3-foot square. It beeps at every corner, flashes the LED at every corner, and then it ends up where it started. So it's a good way to understand motor controlling, how to turn sounds, how to do lights with LEDs, for example. All right, here's a little bit of what that lab looks like. Okay, so you have some instructions, okay, that tell you what you need to do. Navigate in that 3-foot square. Here's some students assembling their robots here, having some fun. It gives you a little bit of a background about the Arduino, and we're going to go into depth in every video that you'll see. But this is the computer that we're programming for the robot. But it's very detailed. It goes into step by step of what you need to do. Okay, it even shows you some electronics in case you've forgotten that some of the sensors have polarity in them. Okay, so we're gonna go into cover each one of these things as we do the videos for each one of these labs. Okay, so it's very exciting things, and can't wait for you to start having some fun with this. To get the connections, how to connect the motors, and you got some code along the way that shows you how to test the components as you plug them in, how to calibrate the servos, and again, we'll go into details as we do each one. But real quick, let's go to the next one. By the way, I got tons of examples on how to do things. There's even songs in here. There's some Star Wars songs, Tetris song, on how to, so that you get motivated as you build this. You can do all kinds of things. You can do keyboard navigation. You can control your robot with the keyboard, for example. These are very exciting things that back in the day used to be very difficult to do. But now you just write some code, wire up your robot, and you're good to go. When I used to do this back in the day in the 80s, this took a long time, many days to get to do something like this. Real quick, I also want to show you what the report looks like. So here's one. Let's see what this student did back in the day. So robot, you have the objectives, the description of the project, right? So what is it that you're doing? What did you do? And then you want to put in some more data in here, and I also want to see your code, right? Exactly how you program it, and that's it. A little conclusion. Okay, so what's the purpose of the project? What did you do? And then a conclusion of what did you find out? What problems did you have? Those kinds of things. and I just want to see your robot, how you wired it a little bit, and code. Okay, there's many ways to do it. Here's another one. Another person who, by the way, there's a free software out there called Fritzing that will allow you to draw this very easily just by dragging and dropping components, and then you can do some really nice lab reports with it. Alright, lab number 2, feelers. Let's open that up. Experiment 2. Okay, on this one you're going to use these little feelers and infrared sensors, so you're going to have to use this little sensor switches here, and you will navigate with it, and the robot is going to go around the room, and if it senses something in the front, it'll back away. But if it doesn't see like the leg of a chair, for example, you'll have switches as extra sensors. But we're going to be learning quite a bit. We're going to be learning about syncing and sourcing and microcontrollers. This is going to be really exciting stuff. Okay, so this is one of the things that I love to do. I love to experiment with these things and create these labs. And so, as you can see, there's a lot of things. One of the cool things about this particular one is the example of escaping a corner, right? So this is if your robot gets stuck in a corner because it hit the left switch or the right switch, it could be there forever doing the same thing, left, right, and it never gets out of the corner. So I show you how to do a little bit of AI in there, a little bit how to creating an AI algorithm, and we're going to be using things like if the robot has done the exact same motion for four times, then that means that it's stuck in there. So move on to the next level and try to do a different motion and get out of there, get out of that corner. I like these infrared sensors because they're adjustable, so they're really good. You can adjust the distance that they sense at, and we're going to be connecting them. I also like to give you the specs of the sensor, so not just, hey, plug the sensor and away you go. I want you to see a little bit more about the specs of the sensor. What chipset do they use inside that sensor? Because when you're designing or building a product, these are the kinds of things that you're going to need, right? All right, so I gave you all kinds of details about what infrared is, speakers, and how to connect the speakers, and how to make sound, and how to make some songs. If you're a musician, you'll appreciate that. Again, sample student reports. Oh, this is the code actually. So let's go over here. Again, Fritzing is the software that you're going to be using to write the graphics that you see there. All right, so let's go to the next one. The next one is sonar, and sonar is a sound-based sensor. So let's take a look at this video real quick.
We're about the wrong way. The other way.
So not only are we using a sonar sensor, but we're rotating the sensor so that the sensor locates if there's an object in front of it. That's a 3D printed sensor bracket. I'd show you and teach you how to 3D print. So if you have a 3D printer, I'll show you how to design those brackets and how to print them. It's kind of exciting to see these things because the little robot looks like it's alive. By the way, the bracket for the sensor was designed by a student. So you design whatever you want. Some people do like Mickey Mouse ears, you know, Batman faces. It's as creative as you want to be. So that's the beauty of the class. This lets you be as creative as you want to. This is a little bit more of the solution. Oh, I'll show you a little bit more what it's doing.
Hey,
You see the sensor on the right hand side here? It clicked it, so it knew to turn to the other way and then get out of there. Okay, so in your home, you can actually put some boxes around or something like that, and you can create a maze in there that your little robot can navigate in. Okay. So you can do this anywhere you want to. Let's open up those instructions and see there's so many examples, and I love the sonar sensor. The sonar sensor is one of the most exciting ones. Let's open it up real quick. Okay, so there's a little robot with the sonar sensor. The kit comes with this plastic clear bracket, but again, you can design your own. You can use this open source design program called OpenSCAD, or if you're familiar with any other 3D design software, you can use it. You can use that too. I like this one because it's very trig based and programmatic, so I like to program the circles and things like that and render it, and then I create my own brackets that way, and then you can 3D print them, right? You save the file and then you can install the bracket. So very, very neat stuff. I give you the specs for the sonar sensor, and then I'm going to give you some sample code and libraries. Libraries are pieces of software that allow you to program this in an easier way with less lines of code. So I show you how to test the sensor, right? Make sure that it's working. I give you some samples of what to do with it, but then it's ultimately up to you. It's up to you to figure out how to put these pieces together. You are an integrator of all of these things, and ultimately it's up to you to figure out at the end how to put everything, all the tips that I give you to navigate. So in the first labs, you learn how to navigate, right? You learn how to control a motor, and so you will apply the exact same examples that you did in the beginning to this one. So this is just expanding upon the first examples. Lots of things on 3D printing. Let's go to number 4, infrared sensor. So this one right here, the idea is for you to use a little infrared remote control to control your robot, and this one has some interesting software. The infrared signals are encoded in hex values, so you'll learn how to do that. You'll learn about case statements. So this is very software driven, and it's really neat. You'll be able to make the robot go forward, backwards, left, right, depending on the signal that is received. You can also play different songs depending on the button that you press. So it's a pretty interesting little project. The next one is line following, and for line following there should be some videos here. Yeah, here's line following. So the robot starts here, it goes around the maze, it does like a U-turn at the end there, and then it's supposed to go back to where it started from. Okay, so there he goes. I often put some obstacles, so it has to avoid the obstacle. It's got to go around the obstacle by itself, and then see, like that one failed. There's that other little guy there. He's a little bit smarter. He knows what to do. Alright, so skip that and then it continue.
Mine found it. Why didn't you find it? Mine didn't.
So there's always people questioning how this is done. This is actually my little robot that made it.
You got it.
Right, and then it ends right there. So this is a really, really nice. We do a competition to see who does it the fastest. And let's see. Again, I am providing quite a lot of data in there, and you're going to be using this particular infrared sensor here. It shows you how to connect it, specs on the sensor again, very important. Okay, lots of examples, but ultimately it's up to you to calibrate everything and to make sure that it works. And the last one here, but not the least, is the sumo competition. Okay, so the idea is that your robot goes around and looks for the opponent. The opponent's supposed to be moving, but for some reason this one is kind of dead. Supposed to find the opponent, and I got some samples on YouTube somewhere that are really exciting of the competitions over the years. And so the little robot's supposed to kick him out of the ring, basically, after it finds it. All right. Let's see. So we got that, and that one, the instructions, let's take a quick look at it. There's a lot of things that you have to be able to do with this one in order to be able to get it to work correctly. First of all, you're going to be changing the front. You have that little ramp now in the front instead of the switches. And there's some rules, right? You got 3 minutes to look for your opponent and kick him out. And there's instructions here how to install everything, but we'll have videos on how to do all these things too. Okay, so very exciting things. Again, you're gonna have to figure out a lot of it at the end there. I gave you some basic sample code on how to test things, and then you have to integrate it. There's another one here, and this one only if we have time, but this one here, the idea is on how to use a Bluetooth module to control your robot via a telephone app. So I show you how to build it, then I show you how to use an existing app if you want to, but I also show you how to create your own app using the MIT App Inventor, and then how to use code in Arduino to control it. Okay, so very basic. You connect to the robot via Bluetooth. You can go front, back, left, and right, but you can also use this app that has already been created, where you can actually navigate with like a touch wheel like that on your screen. But the nice thing about this one is that you can actually get sensor data back into the cell phone. Okay, so that one was built by this particular app was built by someone else. But the one that I did was a very simple one, just to give you an idea on how to navigate forward, back, left, and right. Just making a little RC car type of thing. Very exciting. And then there's another one, and only if there's time, which most of the times we run out of time. But there's another one if you want to experiment with accelerometers. There's also a moisture sensor, and there's also how to make video games with your little robot. So there's so many exciting things in there, but that could be something that you do on your own or for your senior projects. Okay, there is an assembly manual in here as well, and the assembly manual should be really detailed, and there's also a parts list with every part that came with your kit. And here's the assembly manual, and the manual again is really detailed. This manual has been used quite a bit by a lot of people, and there's also a sheet that comes with your kit with a ruler that shows you what screw sizes are what. It comes with the screwdrivers that you'll need to assemble it. Comes with all the parts, all the different motors and things like that. And then it shows you detail by detail how to assemble all these things. Okay. No soldering required, you just have to assemble things and wire some things, and at the end of the day you will have a full done robot. Like I said, I have a lot of experience, so in 15 minutes I can assemble one, but we'll do a video on how to do this. Alright, so I hope you're excited as I am of working with our little robot and building a robot that's intelligent and you know, you can impress all your friends with. Alright, we'll see you soon.
Oh, very cool.
All right, so let's test our little robot here. Hopefully it can reach my signal. So it's going forward. Stop. Let's go backwards. All right. Make a turn. Make the other way. Go forward. Stop. Go backwards. Stop. Play a song. And then we have to wait till that loop finishes for that function for the song finishes. Then we can go ahead and go forward again. Okay. Let's see if it finds the line. Oh, it found it. Like barely. You see that? By like a millimeter.